hello dear students. Welcome to our channel Maths with Panindra. In this video, we are going to discuss about exercise 9B probability problems. Let us have a discussion. The first question in this session. If 4 failed coins are tossed simultaneously, then find the probability that 2 heads and 2 tails appear. 2 tails and 2 heads appear. First, we have to know about what is the sample space when 4 failed coins are tossed. In the earlier classes, we discussed about the tossing of a coin. In an experiment of tossing of a coin, if you toss one time, you will get either head or tail. Therefore, the sample space is S equal to H comma T. Suppose if you are tossing the coin twice, so H comma H, H H, H T, T H, T T. These are the possibilities we are getting. Like this way, 4 failed coins are tossed. So we will expect that total number of outcomes in the sample space are 2 power 4. One time if you toss a coin 2 power 1. Twice if you toss a coin 2 power 2. Thrice if you toss a coin 2 power 3. Similarly, here 4 coins are tossed simultaneously. That means 4 times we are tossing. Therefore, the number of possibilities are total number of possibilities in the sample space. So, 2 power 4. Here, 4 coins are tossed. 4 coins are tossed simultaneously. Then the total possibilities or total number of outcomes, better to write, total number of outcomes, n of s equal to, in the sample space we have 2 power 4, that is equal to 16. So total possibilities we got it. Next, let E be the event of getting 2 heads and 2 tails. Getting 2 heads and 2 tails is, so E be the event of getting 2 heads and 2 tails. This is equal to the number of ways of arranging, the number of ways of arranging 2 heads means what? H only, no? 2 heads, TT. In the blanks, in the permutation combinations, in the blanks. So total 4 things are there. In that 2 H are alike, 2 T's are alike. Therefore, n of E equal to, we can write it as 4 things can be arranged in 4 factorial divided by 2H are alike. So it can be done in 2 factorial. 2 tails are alike, 2 factorial. So 4 factorial is equal to 24 divided by 2 factorial is 2 into 2 factorial is 2. 24 by 4, that is equal to 6. Therefore, the probability of getting 2 heads and 2 tails is P of E equal to N of E by N of S. So what is N of E? We got it as 6. By N of S, 16. So 2 3s are 2 8s are. So the required probability or the probability of getting 2 heads and 2 tails is 3 by 8. Sir, this method I cannot understand. So what can we do to get N of E? So here just I am explaining how we will get these 6 possibilities. 2 tails and 2 heads we want to get it. See what are the possibilities I am writing. In this HHTT, the possibilities what we are getting is, how we are getting this N of E is 6. I am giving here. So observe carefully. HHTT, one possibility. Can we write like this now? HT, HT. Next, interchange these places. TH, TH. Next, interchanging of these completely. TT, HH. Just the places we are changing. But 6 possibilities will get in that way only. Next, H at last and ending and beginning and TT. There is no this type of HTTH arrangement. Next, TT at last and HH in middle. These are the possibilities we have, TT and HH in middle. These are the 6 possibilities only we got it here, dear students. I hope you understand that how we are getting. This indicates E is equal to 6 possibilities we are getting now. N of E is equal to 6. Here by using permutations and combinations we got it. Here by using probability. These are the out of 16 possibilities. These are the favorable possibilities. I hope you understand that. We'll move on to the next question. The next question. Find the probability that a non-leap year contains 53 Sundays and 52 Sundays. So find the probability that a non-leap year contains 53 Sundays and 52 Sundays. 2 questions are there. Observe carefully, dear students. The first question, before that, going to do the answer. Non-leap year contains 365 days. These 365 days can be divided in weeks. 52 weeks. How to get this value, sir? Divide by 7. Why? Because number of days per a week is 7. 365 by 7 if you do that. So 7 into 52, 364. 1 day extra will come. These are the weeks. 1 day. That extra. So 365 days can be divided into 52 weeks plus 1 day extra. Now come to the question. General question. 53 Sundays they are asking. Before that you write number of days per a week. The number of days in a week. So it is equal to 7. So total number of days in this, that is N of S is equal to 7. In the week, we have 7 possibilities. They are asking to find the probability that 53 Sundays it has. 53 Sundays. 52 weeks means 52 Sundays will be there, no? We want 53 Sundays. So the extra 1 day should be a Sunday. Then it will becomes 53 Sundays. So how many possibilities are there? Only one possibility out of 7. These 7 possibilities are what? what are the 7 possibilities? Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. These are the 7 possibilities. Among these, that extra day will be Sunday. Therefore, let E be the event of getting 53 Sundays. In brackets, you have to mention the extra day becomes Sunday. The extra day must be a Sunday. Must be Sunday. Then, so probability is only one extra day. The extra day. So n of E equal to only one day. To get 53 Sundays, 52 weeks means 52 Sundays we got it. But extra we want 53 Sundays now. So the extra day must be a Sunday. So that extra day means only one. N of E. Therefore, the probability of E. Therefore, the required probability. Otherwise, the probability of getting 53 Sundays is P of E is equal to N of E by N of S. That is equal to 1 by 7. The second question we have. What is the second question? 52 Sundays. The question is 52 Sundays. In the previous sessions about events we discussed, in that complementary event is there. The relation between event and complementary event. Event is denoted by E and complementary event is denoted by E bar or E power C. That means E complement, it is denoted by like this. The relation between E and E complement, P of E plus P of E complement or E bar is always equal to 1. P of E plus P of E complement is equal to 1. By using, we can do that second question, 52 Sundays. Otherwise, generally also I will explain. So here, what I am taking is, let E bar or E complement is an event of getting 52 Sundays. So 52 weeks means 52 Sundays only will get it, no? In this case, that extra day will be Sunday. If that extra day is not Sunday, so 52 Sundays only will come, no? That extra day is not Sunday. So other than this one, what possibilities are there? Rest of 6 will be there. Other than Sunday, 6 possibilities we have. Let E complement be the event of getting 52 Sundays. In brackets, you mention that the extra day not a Sunday. The extra day, it not a Sunday. Not a Sunday means what possibilities are there? Monday or Tuesday or Wednesday or Thursday or Friday or Saturday. 6 possibilities are there. So N of E complement. So here only I am writing what are the possibilities which are no need to write. Except Sunday remaining 6 are there, no? 6. So therefore the required probability P of E complement, the probability of getting 52 Sundays P of E complement equal to N of E complement by N of S. So N of 6 by 7. Sir, what purpose you said that formula? Even if you apply that formula also, P of E complement I want now. From this result, or not is. Or P of E complement is equal to 1 minus P of E. So 1 minus P of E value we got it now here 1 by 7. So 7 minus 1 by 7, that is equal to 6 by 7. Even in that way also we can do that. So either this one or this one you can approach. This is by using complementary property, and this is by using general definition of probability. So N of E complement by N of S, 6 by 7. I hope you understand that, dear students. We will move on to the next question. Next question number 3. Two dice are rolled. Two dice are rolled. What is the probability that none of the dice shows the number 2? So first of all, N of S, what is the sample space when two dice are rolled? Two dice are rolled. The possible outcomes are, so one die if we throw 1 or 2 or 3 or 4 or 5 or 6 possibilities we have. If we throw a die twice or two dice rolled, so 1 comma 1, in the earlier classes I already discussed that video, dear students. 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6. Like this, 2 comma 1, 2 comma 2 and so on, 2 comma 6. 3 1, 3 2, 3 3 and so on, 3 6. Like this and so on, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So total 36. 6 square. So when two dice are rolled, 36 possibilities we are getting. So that means 6 square. If we throw a die one time, either 1 or 2 or 3 or 4 or 5 or 6, these possibilities are ready. Twice if we do that, 6 square, like, just I am showing here, 1 comma 1, 1 comma 2, 1 comma 3, like this, and so on, 1 comma 6. Similarly, 2 comma 1, 2 comma 2 and so on, 2 comma 6 and so on, 6 comma 1, 6 comma 2. In the last class I said that 6 comma 6. These are the possibilities. 36 possibilities are there. This 36 only we are writing as 6 square. So these are the possibilities. In this, we are assuming that now this is N of S. Total outcomes means N of S. N of S is equal to 6 square. Let E be the event. Let E be the event of getting none of the dice shows 2 is N of E is equal to, what are the number it will be? So, two ways I am saying that. First way, observe carefully, dear students. 6 possibilities are there when one die will be thrown. 2 dice means 6 square. But the question is, required one is, E be the event of getting none of the dice shows 2. We don't want to see the number 2 among the 36. So if we do not take 2, what are the rest of the numbers? 5 numbers are there. 5 numbers, how many times they are rolling the die? 2 times. So 5 square. Here 6 numbers are there, twice means 6 square. None of the dice shows 2. So remaining possibilities are 5. So 5 square. Sir, how you will get 5 square means 25. What is the number? So observe carefully. 1, 1, 1, 2, 1, 3 and so on, 1, 6. 2, 1, 2, 2, 2, 3 and so on, 2, 6 and so on. 6, 1, 6, 2, 6, 3 and so on, 6, 6. So in this 36, the number contained 2 cannot be taken. So 1 comma 2. Next, the number it contains 2. 2, 1, 2, 2, 2, 3 and so on, 2, 6. 3, 2, 3, 4, 2, 5, 2, 6, 2. These total 11 are there. Out of 36, these 11 you have to separate it. The rest of the numbers not containing the number 2. So which are 25. Both are same only. So therefore, the probability of getting the none of the dice shows 2 is P of E equal to N of E by N of S. So what is N of E? 5 square. N of S 6 square. Can we write like this? 5 by 6 whole square? We can write it. That is the answer, dear students. I hope everyone understand that way. 2 ways I explained. Whichever you feel easy, that you can consider. We'll move on to the next question. Yeah, the next question, dear students. Question number 4. In an experiment of drawing a card at random from pack of cards or pack, the event of getting a spade is denoted by A, and getting a picture card, that means either king or queen or a jack, is denoted by B. Find the probabilities of A, B, A intersection B and A union B. So here the question is related to pack of card, drawing a card. From the pack of card, drawing the card. In an experiment of drawing a card, what are the total number of cards in the pack of card? So total we know that 52 cards are there. In these 52 cards, 26 red, 26 black cards are there. So in that 26 also, 13 cards, clubs, again 13, diamonds, one more 13, hearts, clubs, diamonds and 14. So total like 4. Exactly I did not know, but these are the possibilities are there. 13 possibilities are there. So in every set of 13, the picture card is available. In every 13, king, queen, jack will be available. So total 13 cards now. So first N of S you have to write it. The number of cards in a pack equal to 52. So in the pack of cards 52 are there. We want only one card we have to select. Drawing a card at random. So the total number of outcomes is 52. In that one card we are selecting. So the total number of cards n of s is equal to, out of 52 we have to select one card now. So 52 C1, that is equal to 52. N C1 is equal to n. Getting a chord, n of s is equal to 52. Next, the event of getting a spade is denoted by A, capital A. So let A be the event of getting a spade chord. So then one card we have to draw anyway. So how many spade cards are there? We already discussed that 13 spade cards are there. So let A be the event of getting a spade card. Then the number of ways of selecting or drawing. Then the number of ways of drawing a chord. Drawing a chord is n of A is equal to, out of 13 spade cards, one card we are selecting, 13 C1, that is equal to 13. After completing of n of A, immediately you can get the probability also. Therefore, the probability of getting a spade chord from a pack is P of A is equal to n of A by n of S. So n of A 13 by n of S 52. So 1 by 4. Otherwise you can leave it like this. Not a problem. Next, we have finished that first set. Next, what about that B? Getting a picture chord. So let B be the event of getting a picture chord. Getting a picture chord. See, picture chord means here you have to get that idea, dear students. In these 13, 3 picture chords are there. That means king, queen and jack. Even in this set also, king, queen, jack. Even in this set also, king, queen, jack. In this set also, king, queen, jack. So total how many picture cards are there? 3 plus 3 plus 3 plus 3. Total 12 are there. So let B be the event of getting a picture card. Then the number of ways of drawing a picture card. Drawing a picture card is n of B equal to, so picture cards, the 12 are available. So 12 C1, everyone will get out how it will come 12. See here 3 picture cards, here also 3, here also 3, here also 3. So 3 plus 3 plus 3 plus 3. So it will be 12. Out of 12 picture cards, one picture card can be selected in 12 C1. Therefore, n of B is equal to 12. I hope you are able to see now once. So therefore, conclusion step here only I am giving. The probability of getting a picture card is P of B equal to n of B by n of S. N of B means what? 12 by n of S is 52. So 12 by 52. Even here also you can leave it like this, not compulsory to. Even by 4 table also you can do 4 3s or 4 12s or 4 13s. But no need to simplify. Why? Because ultimately we need to calculate A intersection A union. No. Next, after A, D, this P of B is over. So P of A is also over here. Next, A intersection B. What are the common thing? Let A intersection B, the chord selecting from spade and the chord selecting from picture chord. In the spade, 13 chords are there. The picture chords only in the spade, how many are there? 3 are there. So in the spade, 3 picture chords are there. Even in this also, 12 out of 12 picture chords, 3 picture chords are common, no? So n of A intersection B is equal to the number of directly I am writing now here n. N of A intersection B is equal to the number of ways of selecting a chord. A intersection B means the chord which is drawing from either A and B, not A and B. So intersection. Intersection means common. So in A is the event of getting a spade chord. So in that spade chord, set of 13 are there on the spade. In the 13, how many picture chords are there? 3 picture chords are there. B is also picture chord. So total 3 will be common. Selecting a chord in 3C1 ways. The number of ways of selecting a chord in 3C1 ways. Therefore, n of A intersection B is equal to 3C1, which is equal to 3. Observe, dear students, how we are getting 3. In this 13, K, Q, J, 3 picture chords are there. In only B event means 12 picture chords are there. So that means 4 kings are there, 4 queens are there, 4 jacks are there. So all are picture cards are, so these 3 will be common. That is the reason n of A intersection B equal to 3. Therefore, the probability of getting, here we cannot mention directly the method, getting picture chord in common. Otherwise, directly you can write, no need to write the probability of getting. So P of A intersection B. Therefore, P of A intersection B is equal to n of A intersection B divided by n of S. N of A intersection B is what? 3 divided by n of S, 52. So last one, this is the third category. Last one is A union B, the probabilities of A union B. So P of A union B is equal to, by using addition theorem on probability, theorem on probability, now P of A union B equal to P of A plus P of B minus P of A intersection B. So this is the statement of addition theorem on probability. So what is P of A? P of A is 13 by 52 plus P of B 12 by 32, sorry 52, minus P of A intersection B 3 by 52. So take LCM 52. 13 plus 12 minus 3. 13 plus 12, 25. 25 minus 3. 25 minus 3 is 22 by 52. So 2 table. 2 11s, 226. So therefore, P of A union B is equal to 11 by 26. I hope you understand, dear students. We'll move on to the next question. Yeah, the next question. Question number 5. In a class of 60 boys and 20 girls, half of the boys and half of the girls know cricket. Half of the boys and half of the girls know cricket. Find the probability of the event that a person selected from the class is either a boy or a girl who knows cricket. Here first you have to assume the events. So first, in a class, how many boys are there, how many girls are there? So here 60 boys are there, 60 boys and 20 girls are there. So 60 boys and total 80 persons are there. So total 80 persons. Let, here PG already used, no? So event 1, event 2 or A1, A2. Here I am assuming that let E1 be the event of selecting a boy. So what are the possibility? How many boys are there? 60 boys are there. So n of E1. So total 80. So n of E1 equal to, out of 60 we can select one boy in 60 C1 ways, that is equal to 60. So total 80 means n of S is equal to 80 C1. One person you can select 80 C1 80. So therefore the probability of the person, therefore the probability of selecting a boy is P of E1 is equal to n of E1 divided by n of S. So n of E1 is 60 by n of S is 80. So E1 information completed. Next, E2. Let E2 be the event. See here. In a class of 60 boys and 20 girls, half of the boys and half of the girls know cricket. Find the probability of the event that a person selected from the class is either a boy selection completed, or a girl who knows cricket. Let E2 be the event of selecting a person who knows cricket, who knows cricket. See, observe carefully, dear students. A condition will be there, half of the boys and half of the girls know cricket. So how many boys are there? 60 boys are there. So half of the boys in that 60 is 30 boys plus half of the girls 10. So total 40 persons. So from this 40, you can select one person, the probability of E2 will come. Therefore, the probability of E2, that means E2 means I already mentioned here, P of E2 is equal to, before that N of E2 we need to calculate, no? Here only we can write it. N of E2 is equal to 40 C1, that is equal to 40. Out of 40 persons only, here they mentioned clearly, or a girl, either a boy or a girl who knows cricket, from the person especially. So P of E2 is equal to N of E2 by N of S. So that is equal to 40 by 80. You don't cancel it, you can leave it like this. Next, intersection part. Here or they mentioned, no? Or they mentioned. The probability of the event that a person is selected from the class is either a boy or a girl. So N of A intersection B, N of A intersection B is equal to, in this intersection part, observe carefully, this is important one. Half of the girls know cricket, half of the persons, here the person selected from the class is either a boy or a girl who knows cricket. In this, half of the boys means the intersection part. Who knows that cricket? In this half of the girls knows cricket. So 10. Half of the, in this 40, what is the common thing? So only girls knows cricket over here. A girl who knows cricket. A girl who knows cricket means only 10. So out of these 40, the 10 you can subtract in the common things. Who knows cricket? If you subtract, you will get 30. So 30 is C1. So N of A intersection B is equal to 30. So therefore the required probability P of not A, B, ma, here E1, E2, no? I wrote already E1, E2. E1 intersection, E2 it is. N of E1 intersection E2. N of E1 intersection E2. 30 C1. Therefore probability of E1 intersection E2 equal to N of E1 intersection E2 by N of S. What is N of E1 intersection E2? 30 by 80. Therefore, the probability of the event, the probability of the event that a person selected from the class is either a boy Either a boy or a girl who knows cricket. A girl who knows cricket is, so P of E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. So P of E1 60 by 80 plus P of E2 40 by 80 minus P of E1 intersection 30 by 80. So that is equal to 60 plus 40, 100 minus 30, 70. So that is equal to 7 by 8. Therefore, the required probability P of E1 union E2 is equal to 7 by 8. Next question, dear students. Question number 6. In this question, they are asking to prove probability of A complement intersection B complement equal to 1 plus P of A intersection B minus P of A minus P of B, where A comma B are any two events. To prove this result, we have to get the De Morgan laws, which we studied in the earlier classes like 8th class, 9th class and 10th class in set theory. So we have first step, we write it whatever it is given, A comma B or A and B are any two events of an experiment in a sample space of a sample space. We have from De Morgan laws, A complement intersection B complement can be written as A union B whole complement. This is from De Morgan laws. But they are asking the probability of A complement intersection B complement, taking probability function on both sides. P of A complement intersection B complement is equal to probability of A union B whole complement. We know that P of E plus P of E complement is equal to 1. So from that P of E complement can be written as 1 minus P of E. So by using this property, P of A union B whole complement can be written as 1 minus P of A union B. By using addition theorem on probability, P of A union B value, we know that the formula we have 1 minus, keep bracket, P of A plus P of B minus P of A intersection B. So actual multiplication 1 minus P of A minus P of B minus into minus plus P of A intersection B. So therefore write first positive values 1 plus P of A intersection B minus P of A minus P of B. That's what they are asking to prove. So this is our required LHS and this is RHS. Hence prove. We will move to the next question. Next question. This is important type question. Two persons A and B are rolling a die on the condition that the person who gets 3 will win the game. Then find the probabilities of A and B respectively to win the game. So two persons A and B are rolling a die. So first step, when we rolled a die, the total possibilities, the total outcomes are 1, 2, 3, 4, 5 and 6. When we rolled a die, the total outcomes are 1, 2, 3, 4, 5, 6. Here, condition is given. Rolling a die on the condition that the person who gets 3 will win the game. If the die shows, if the die shows the number 3, the number 3, the person will win the game. The person will win the game. Otherwise, we know that the person will fail. So, what are the possibilities to get the number 3? So, out of 6 possibilities, to get the only number 3 is only one time, no? So, it will be success. Why? Because here will win the game, they are saying. That is, that I am considering P is equal to 1 by 6. Why we are writing 1 by 6? Out of these 6 numbers, 3, if 3 will come, the person will gain, the person will win the game. So obviously, we know that whenever the 3 number will come, the person will win, no? So other than 3, what are the possibilities? 5 possibilities are there. So obviously, whenever the other numbers will come, the person will fail. So the die shows the rest of the number, the rest means rest of the numbers. Then the person will, then the possibility, then the person fail or losing the game, game is Q equal to 5 by 6. So when the person will win the game, 1 by 6, lose the game, 5 by 6. Till here completed. No? After that, then find the probability of A and B respectively to win the game. I think the question, if game starts by A, that is the question. If game starts by A, the person A will start the game, he may wins, 1 minute now. Yeah. The person A will start the game, he may wins in the first try, first, third, fifth, and so on tries, and so on tries. So that means the probability of the person A, that is P of A. So the person start the game with A, no? So he rolled a die. So we got directly the number 3. So first way. So whenever he got 3 number, what is the possibility? 1 by 6. So like this first you write it. P. He succeeded the game. Whenever succeed the game, again they have to start now. Plus next possibility. Again the person A start the game, but he did not win the game, he lose the game. So lose the game means after that, lose the game means what are the possibility? Q. Again B has to take that die. If B throw a die, we'll get it as, again he did not get it. Why? Because A will win the game, they are saying that. So again B also will fail. Whoever will fail the game, it will be Q only. So the failure is 5 by 6. Next, whenever fail the game, again he has to start. A person has to start. So in the third try, he may get 3 number. So whenever he gets 3, again he will win the game. So P. Like this. Or whenever game he got that number 3, stop the game, and these are the possibilities. Again the person start the game by A, he failed in the game. Whenever he failed, he can give to the other person B. Again he also rolled the game number and he got another number other than 3. So he did not get, he failed. Again A has to take, this time A also, after rolling the die, he did not get that, the number 3, so Q. Again you can take that B person. Again he rolled the game, he did not get. Why? Because A person will start the game, that is the reason. Now the person A will take this, in this trial he is going to get the number 3. Whenever 3 gets, the person A will win. Winning possibility is P. So like this and so on is going to come. Like this P. So you remember, this is very important step. First, third, fifth trials and so on, 7th trial, he is going to win the game. Like this. In this, P I am taking common 1 plus Q square plus Q power 4 plus and so on. So this also can be written as P of A equal to P into 1 plus Q square, Q power 4 can be written as Q square whole square plus and so on. It is sum to infinity. It is in the form of sum to infinity. So sum to infinity formula we have S infinity is equal to A by 1 minus R, where A is the first term, R is the common ratio. What is A in this series? 1. A is equal to 1. Or common ratio T2 by T1, Q square. So P of A is equal to P into 1 by 1 minus Q square. What is P value? 1 by 6. 1 by 1 minus Q square, 5 by 6 whole square, 25 by 36. So if you simplify 1 by 6 into 1 by 36 minus 25 divided by 36. 6 1s are 6 6 are 6 will become here. So here already 6 by 36 minus 25 is 11. So P of A, this is winning possibility of P of A. So whenever this is the probabilities of A to win the game. That is the probability of the probability of A to win the game is to win the game to win the game. So we'll fail the game means what? Whenever A fails, B win only, no, indirectly. So P of A complement is equal to the probability of A to fail the game or to lose the game. To fail the game, that also equal to probability of B. So whenever A fails, automatically the probability of B will come. So P of A fail means P of A complement only, no, so that means 1 minus P of A. That is equal to P of A complement means P of B only. 1 minus 6 by 11, that is equal to 5 by 11. So the probability of the person B will win the game is 5 by 11. The probability of B will win the game is 5 by 11. I hope you understand, dear students. We'll move on to the next question. This is a different question, but this type of question we may expect in the JMNs and MSET also. MSET type questions. Practice thoroughly this type of questions, not only in IPE but especially I am expecting this type of question they will ask in JMNs and MSET. We'll move on to the next question. Next question, dear students. Question number 8. A, B, C are 3 newspapers from a city. So 3 papers are there. A, B, C. So in this 3 newspapers A, B, C. 20% of population read A. That means the probability of 20% of the population will read the paper A. So the probability of A equal to 20%. That means 20 by 100. No need to simplify, leave it like this. Next, 16 read B. The probability of the population who reads B is 16%. So 16. That is equal to 16 by 100. The probability of C. So who reads? 14% read the paper C. So P of C equal to 14%. So that is equal to 14 by 100. Next, 8% both A and B. So the probability of the population who reads A and B papers. That means P of A intersection B. So combination. Both the papers they will read that. So A intersection B is how much it is given? 8%. So 8 by 100. Next, 5% both A and C. So 5% both A and C. A intersection C is equal to 5%. So which is equal to 5 by 100. Next, 4% both B and C. So probability of B intersection C is equal to 4%. that is equal to 4 by 100. So these are the respective probabilities from the question we wrote. Next, 2%, all those three papers they will read. All the three papers they will read means P of A intersection B intersection C is equal to 2%. So that is equal to 2 by 100. Till here everyone understand? It is given easy problem. Find the probability, find the percentage of the population who read at least one newspaper. First you have to know the meaning of at least one of the newspapers they will read. At least one means either one or two or three papers. So wherever you are getting at least one of the possibilities or one of the newspapers based on the question, at least one is given, that time you can apply addition theorem on probability. So addition theorem on probability for two events, here more than two events we are getting, but addition theorem on probability for three events also there. That formula we are going to apply, dear students. See here, these are the probabilities. The probability of the probability of three newspapers who will study by the population of the city, respective newspapers of A, B, C. Here, conclusion one. The probability of the percentage of the population, the probability of the percentage of the percentage of the population who reads at least one newspaper is, so at least one newspaper, P of A union B union C. So by using addition theorem on probability, for three events. So here I am writing P of A union B union C is equal to, so P of A plus P of B plus P of C, after that minus P of A intersection B minus P of B intersection C minus P of C intersection A intersection C or C intersection A plus P of A intersection B intersection C. So this is the formula for addition theorem of probability for three events. So all these values we have substitute and get the answer. P of A 20 by 100 plus P of B 16 by 100, P of C 14 by 100 minus P of A intersection B 8 by 100 minus P of B intersection C 4 by 100 minus P of A intersection C 5 by, B intersection C is 4 by, A intersection C is 5 by, plus 2 by 100. So all these values substitute, anyway LCM is same, so you have to add and subtract respective terms in the numerator. 100, 20 plus 16 plus 4, plus 14 minus 8, minus 4, minus 5 plus 2. So which is equal to 16 plus 14, 30. 30 plus 20, 50. 52. Minus 12 minus 17 by 100. Which is equal to 35 divided by 100. 3500. That means 35%. I hope everyone able to understand that. So this is the last step. By using addition theorem of least, this is the required one. The probability of the percentage of the population who read at least one newspaper is P of A union B union C. That is equal to 35%. We'll move on to the next question, dear students. The next question, dear students. If one ticket is randomly selected from tickets numbered 1 to 30, so total 30 tickets are there, then find the probability that the number on the ticket is a multiple of 5 or 7. So 5 or 7. Suppose if you are assuming A is the event of getting the number on the ticket is 5 multiple. B is the event of getting a number is a multiple of 7 on the ticket. So A, B are there. Next, common things, common numbers which are coming on the ticket from the 1 to 30. That you can find. Whenever 5 or 7, A or B means P of A union B. Addition theorem on probability we can apply in both the questions here. Step by step we will discuss. So total how many numbers or how many number tickets are there? 1 to 30. So total number of tickets. That means these are the total outcomes. In the sample space 30 are there. Total number of tickets. So 30. Out of 30, one ticket can be selected randomly. So, one ticket can be selected in 30 C1 ways. That means N of S equal to, that is N of S is equal to 30 C1. 30 C1 means 30. Keep in mind, dear students, N of S is 30 C1, that is 30. First step from the given information only. Next step, let A be the event, A or E1, E2, your wish, anything you can take. A be the event of getting the number on a ticket is 5 multiple that is what are the possibilities? A is equal to 5 multiples till 30 you have to write it. 5 ones are, 5 twos are, 5 threes are, 5 fours are, 5 fives are, 5 6 are. We can write till here only. So N of A, how many numbers we have? 6 numbers we have. Therefore N of A is equal to, out of these 6, one number can be selected in 6 C1 ways. That is 6. Therefore the probability P of A is equal to N of A by N of S. That is equal to 6 by 30. Don't cancel. Why? Because 6 1 to 6 5 in the next we can take the LCM and do it. Next, let B be the event. Let B be the event of getting the number on a ticket is 7 multiple. 7 multiple means till where we have to write it? That is B is equal to 7 ones are, 7 twos are, 7 threes are, 7 fours are. We cannot write 7 fives away because 35 it is more than 30. So only till 30 numbers, whatever the numbers we have, that we can write it. 7 multiples. So how many possibilities are there? 4 possibilities are there. Therefore n of B is equal to, out of 4 numbers we can select any one, 4C1 ways. Is there any common number in between A and B? A intersection B. Third one, A intersection B. There is no common element in these two sets. So, by taking probability on both sides, P of A intersection B is equal to P of phi. P of null set. Probability of null set is always 0. After completing of this step, they are asking a multiple of 5 or 7. Therefore, the required probability P of A union B equal to, right, by using addition theorem on probability, P of A plus P of B minus P of A intersection B. So what is P of A? P of A we have that 6 by, sorry, here I did not complete P of B. Here only I will write it, N of B by N of S. N of B is what? 4. 4 by N of S is 30. So P of A 6 by 30 plus a P of B 4 by 30. P of A intersection B value 0, we got it here. So 6 plus 4, 10. Why? Because denominators are same now. So 10 by 30, that is equal to 1 by 3. Therefore, the probability of getting a number on the ticket is a multiple of 5 or 7 is 1 by 3. I hope you people understand that. We will move on to the same procedure for the next question. A multiple of 3 or 5. 3 or 5. Same procedure we have to follow. But in this case, 3 and 5 multiples are there which are common. So first one, the B problem, which is A. This is A problem, this is B problem. Here already A, B I have taken, so C, D I am taking, general. Let, otherwise E1, E2. C be the event of getting a number on the ticket is a multiple of 3. So that is C is equal to 3 multiples you have to write till 30. So 3 ones are 2, 3 tens are. So 3, 6, 9, 12, 15, 18, next 21, 24, 28, 27, 30. Out of these numbers, one number can be selected in N of C. 10 numbers are there, 10C1, that is equal to 10. So 10 numbers are there. Similarly, next D be the event of getting multiple of 5 multiples. So let, this question is different, this question is different. This is the second question, both separate. So let D be the event of but possibilities will get same, but we need to write like this only. event of getting a number on the ticket is a multiple of 5. So that is D is equal to multiples of 5, we write it like this way. So 5, 10, 15, next 20, 25 and 30. 1, 2, 3, 4, 5, 6. From these 6 numbers, one number can be selected in n of D is equal to 6C1, that is equal to 6. As soon as getting n of C, immediately you can calculate P of C also. So P of C is equal to n of C by n of S. N of C is 10 divided by n of S is 30. We already calculated. Even here also, n of D equal to 6. P of D is equal to. But here already place is not sufficient. So P of D is equal to n of D by n of S. So n of D is equal to 6 by S, n of S, 30. Next they are asking, find the probability that the number on the ticket is a multiple of 3 or 5. 3 or 5 means C or D, C union D. Therefore, the probability of the required probability means that only. The probability, but here I am writing for this, the probability of getting a number on the ticket is a multiple of 3 or 5. 3 or 5 is P of C union D. We know that by using addition theorem on probability, P of C union D is equal to P of C plus P of D minus P of C intersection D. Here we need to calculate P of C intersection D. That's why P of C intersection D, how it will come? N of C, N of D, we have C intersection D. What are the common elements here? In the C and D, common elements are 15, 30. So two numbers, not only 2 but also only 15 and 30. So there is no other number, only 15 and 30. So 15 and 30. These are the common numbers, common from this C set as well as D set. So n of C intersection D will become what? 2 are there. So out of 2 we can select 1, 2C1. So it is equal to 2. So what is the probability here? P of C intersection D is equal to n of C intersection D divided by n of S. So n of C intersection D is 2 divided by 30. So this information you need to write it compulsorily. Now substitute P of C. P of C is 10 by 30 plus P of D is 6 by 30 minus P of C intersection D 2 by 30, which is equal to, take LCM 30, 10 plus 6 minus 2, which is equal to 16 minus 2 is 14, 14 by 30. So by 2 table, 2 sevens are 2 15s. Therefore, the required probability, that means the probability of getting the number on the ticket is a multiple of 3 or 5 is 7 by 15. I hope you understand, dear students. We will move on to the next question. See the next question. If two numbers are selected randomly from 20 consecutive numbers, natural numbers, find the probability that the sum of two numbers is an even number and second question is an odd number. So first, dear students, you remember that how many numbers are there here? Total 20 numbers. Total numbers 20. Out of 20, how many numbers are going to select? Two numbers. So two numbers are selecting from 20 in 20 C2 ways. So these are the total possibilities. So that is n of s is equal to 20 C2. 20 C2, how to write it? 20 C2. 20 and the immediate before one, you write it 20 into 19 in decreasing order. By 2 is there, no? So 1 into 2. So we can cut 10 times. So 19 into 10 is 190. So n of s is equal to 190. Till here, I think everyone understand, no? So let A be the event. Let A be the event of getting the sum of two numbers is even number. So sum of two numbers is even number. Out of 20, observe carefully, dear students, 10 even numbers are there, 10 odd numbers are there. To get the sum of two numbers is an even number. Suppose, for example, two even numbers I am taking. 2, 4. Sum is even number only, no? Even, not only sum of two even numbers, or if you take two odd numbers also, sum of two odd numbers, 3 and 5. 3 plus 5, how much? 8. It is an even number. So, the sum of two numbers is an even number. We are getting two possibilities. Therefore, n of A is equal to, from 10 even numbers, we are selecting 2, 10C2, or from 10 odd numbers, we are selecting 10C2. Whenever R is there in that probability, we can consider as plus. Wherever and is there, into. So 10C2 plus 10C2, that is equal to 2 times of 10C2. That is equal to 2 times of 10C2. Just now I said 20C2. In the decreasing order, 20 and 19, two numbers. Here 2 is there, no? 20 and 19. 2 is there here, 1 into 2. So here also 10 into 9 by 1 into 2. 2 get cancelled, 9 into 10 is 90. So n of A is equal to 90. Therefore, the probability, P of A is equal to n of A by n of S. What is n of A? 90. N of S, 190. So 9 by 19. Therefore, the probability of getting here the sum of two numbers. Therefore, the probability of getting the sum of two numbers, is an even number. Is 9 by 19. So whenever A is getting even number possibility, means the complement of A is obviously odd number only. So A complement is the event of getting the sum of two numbers. The sum of two numbers is an odd number. So their probability, that is P of A complement, is equal to, what is P of A complement? 1 minus P of A. That is equal to 1 minus P of A value 9 by 19. So take LCM 19 minus 9 by 19, that is equal to 10 by 19. Therefore, the probability of getting here, therefore, the probability of getting the sum of two numbers is an odd number, is 10 by 19. So even number is 9 by 19, odd number is 10 by 19. We'll move to the next question, dear students. The next question. A game consists of tossing a coin 3 times and noting its outcomes. A boy wins if all tosses give the same outcome and loses otherwise. Find the probability that the boy loses the game. Lost the game. So first, when coin toss, here tossing a coin 3 times, the total possible outcomes when a coin tossing 3 times or 2 power 3. In the previous sessions we discussed that when a tossing of a coin, 2 possibilities, head and tail, 2 possibilities, only one time if you toss 2 power 1, if you toss twice 2 power 2, toss thrice 2 power 3, and so on, n times means 2 power n. So here 3 times we are tossing the coin, so 2 power 3, which is equal to 8. So total possibilities means, is it n of s or not? N of s. Total possibilities. This is the first step. Next, a boy wins if all the tosses give the same outcomes. So among the 8, what are the same outcomes we are getting? See what possibilities are like H, T, H, 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 T, like this it will come, like 8. Among these, give the same outcomes. Give the same outcomes means 3 heads or 3 tails. These are the possibilities are required. So here for that, let A be the event of getting, A be the event of the boy wins and tosses give the same result, same outcome. That is A equal to, so 3 coins we are tossing now. 3 outcomes are same means all the 3 outcomes will be head, 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 or tail, tail, tail. Only these are the sorry, two possibilities only we are getting when three coins are tossed, give the same outcome. This is one outcome, this is another outcome. So n of A is equal to 2. Therefore, the probability of the boy wins the game is P of A is equal to N of A by N of S. Here I already mentioned that when the boy wins, when he is getting the same outcomes, that's what I wrote here. So total N of A is equal to what? 2 by N of S is equal to 8, which is equal to 1 by 4. P of A is the probability of the boy wins the game. But they are asking what? Find the probability that the boy lost the game. So A complement. A complement is the event that the boy loses the game. So P of A complement, the probability, last step. The probability of the boy loses the game is P of A complement. P of A complement means 1 minus P of A. That is equal to 1 minus P of A value 1 by 4. Which is equal to 1 minus 1 by 4. Take LCM 4. 4 minus 1, that is equal to 3 by 4. Therefore, the probability of the boy lose the game is 3 by 4. I hope everyone understand. We'll move on to the next question. Next question, dear students. This is the 12th question, last question in the first section in the exercise 9D. If E1, E2 are two events with E1 intersection E2 equal to pi, then show that probability of E1 complement intersection E2 complement equal to P of E1 complement minus P of E2. So first given E1 comma E2 are two events. E1 comma E2 are two events. Which are the two events? And two events means two events in the sample space, obviously. And given E1 intersection E2 is equal to null set. After that, consider LHS. Now, consider LHS. They are asking to prove the result now. So, probability of E1 complement intersection E2 complement. In this session, I said one of the De Morgan's law. A complement intersection B complement can be written as A union B whole complement. So here also E1 complement intersection E2 complement can be written as E1 union E2 whole complement. So probability of E1 union E2 whole complement. We know that P of A complement is equal to 1 minus P of A. P of A complement is equal to 1 minus P of A. So by using this property, 1 minus P of E1 union E2. By using addition theorem on probability, P of E1 union E2, P of E1 plus P of E2 minus P of E1 intersection E2 Since E1 intersection E2 equal to 5, E1 intersection E2 is equal to 5, taking probability function on both sides. So probability of null set is always 0. So P of E1 intersection E2 is equal to 0. 1 minus P of E1 plus P of E2, this value is 0 only. So each and every time multiplying by minus. 1 minus P of E1 minus P of E2. What they are asking to prove? P of E1 complement minus P of E2. So 1 minus P of E1, by using 1 minus P of A equal to P of A complement now. So 1 minus P of E1 we can write as P of E1 complement minus P of E2, which is required RHS. So LHS, RHS. I hope you people enjoyed the session, and in the next video I will give that solutions in this exercise 9E in the second bit, in the second section. There are also 12 questions I think we have in that exercise. I will explain clearly that problems also. Thank you dear students for watching our channel Maths with Panindra. Those who are watching first time, dear students, please do subscribe. If you like the videos, you can share to your friends and ask them to subscribe. And go to the playlist also, whichever required you can watch the videos. Thank you. Jai Hind, Maths with Panindra.